Welcome back to another training video using the UK Electrical Simulator. In this video we're going to look at the difference between a radial circuit and a ring final circuit, explain where they came from, where they are commonly used, and the typical protective devices used for each type. A radial circuit starts at the consumer unit and runs out to the final point in one direction only, whereas a ring final circuit starts at the consumer unit, but it continues around the circuit and returns back to the same protective device, forming a complete ring. Before the ring final circuit was introduced, UK homes generally used older socket circuit arrangements that were more like radial type systems. The ring final circuit was developed during the post-war rebuilding period as a practical way to install more socket outlets while using less copper and keeping costs down. Today, a ring final circuit is commonly used for general socket outlets in areas such as living rooms, bedrooms, kitchens, etc. In many older houses, it was common to have all the upstairs sockets on one ring final circuit, with the downstairs sockets on a second similar circuit. In later properties, it also became more common to install a dedicated ring final circuit for kitchens, because they usually have a higher number of socket outlets and a greater demand from portable appliances. In modern domestic installations, a ring final circuit is typically protected by a 32 amp RCBO, whereas radial circuits are often protected by a smaller 20 amp, although some larger radials may use a 32 amp, depending on the cable size and overall circuit requirements. We've covered a lot of the theory, so now let's bring it into the simulator and look at the difference between the two circuits in a more practical way. On the workspace, we already have the consumer unit and two bus components in place. For the radial circuit, we'll use C3, which is protected by a 20 amp RCBO, and for the ring final circuit, we'll use C2, which is a larger 32 amp RCBO. Let's begin with the radial circuit. We start by connecting L3 to the line terminal of the first socket and then extend that conductor onto the other three sockets. We then do the same for the neutral, connecting N3 to the first neutral terminal and continuing it through to the remaining sockets. And finally, we connect E3 to the first earth terminal and extend the CPC through to the other three sockets. Now let's energize C3 and switch on the dehumidifier plugged into the first socket. We can see from the circuit meter that it is drawing just over 2 amps. As we switch on the other appliances, the current increases on the circuit meter. Once all 4 appliances are on, we can see that the circuit is getting very close to the 20 amp rating of the RCBO. If we were to add another load, we would eventually exceed that rating and trip the circuit. Now let's move on to the ring final circuit. We begin in a similar way, connecting L2, N2 and E2 to the first socket and then extending the wiring onto the other sockets. To speed the process up, let's open another workspace with most of the wiring already complete. You can now see the line, the neutral, and the earth conductors connected to all sockets, but at this stage it is still only wired like a radial. It does not become a ring final circuit until we connect the final socket back to the circuit 2 terminals. Let's do that now. Connect terminal L on the final socket back to L2 on the bus. Connect terminal N back to N2. And finally connect E back to E2. We now have a ring final circuit. Now energize C2 and start switching on the appliances plugged into each socket. As more devices are switched on, we can see the current rise on the circuit meter. As we continue adding load, we can see the circuit getting close to the 32 amps. Once we switch on the final appliance, the load exceeds 32 amps and the circuit trips. To reset the RCBO, switch off one or more of the loads, then press the C2 button on the bus, or reset the RCBO on the consumer unit. I hope you've enjoyed this video showing the difference between a radial circuit and a ring final circuit, and how overloading either circuit can cause the RCBO to trip. In the next video, we'll look at how to correctly add an additional socket outlet or several additional sockets using a fused spur. Please like, subscribe and leave a comment below.